All right, let's jump right in. What if you could treat your relationships like a software project? Now, I know that sounds a little cold, maybe even kind of weird, but the goal is surprisingly human, to build connections that are way more stable, manageable, and clear by applying the same principles we use in systems engineering. Today, that's exactly what we're going to unpack. So let's really lean into that question for a second. What if you could actually design your personal connections with the same kind of precision you'd use for a super complex piece of software? Imagine being able to debug conflicts or deploy updates to your shared understanding. It's a pretty wild idea, so let's break down how something like this could possibly work.
So here's our roadmap. First, we'll talk about the core idea. What even is a relationship system? Then, we'll look at the architectural blueprint for it. From there, we'll get into the nitty-gritty, the communication rules, the tech stack you might use, and finally, how it all comes together in the real world.
Okay, so let's start with the fundamental thesis. The big idea is this. What if we stop treating human connection as this totally intuitive, chaotic thing, and start looking at it as a system that we can intentionally design to be stable and, a lot easier to manage? Now, the foundation for this whole model is a pretty radical reframing of communication. It's no longer just talking. It becomes data transmission. And success? Well, success isn't just about getting a reply. For this system to work, a message has to be sent, received, fully understood, and, this is the most important part, integrated. That means the information has to actually update the other person's reality and become a new, shared fact between you.
Right, so if communication is data, then you've got to have a network for it to travel on. That brings us to the architectural blueprint. This is where we start modeling all the people in our lives, partners, kids, even the babysitter, as these interconnected nodes in one single, coherent system.
And in any network, you've really got two basic models to choose from. First, you've got a star network. Think of one person, like a parent, being the central hub for all family info. It's super consistent, sure, but that one person becomes a massive bottleneck. On the flip side, you've got a mesh network. This is where everyone talks to everyone. It's definitely flexible, but man, can it be chaotic. You get mixed messages, and there's no single source of truth.
So the proposed solution here is a clever compromise, the hybrid star. In this model, the central hub isn't a person. No, it's the relationship itself. It's the shared rules, the history, the agreements you've made together. This creates this really stable core, but it still lets people connect directly when they need to. You get that perfect balance between control and flexibility, which is absolutely crucial for long-term stability. So let's just quickly break down this hybrid star. The central server, that's the shared system we just talked about. The clients, well, that's just a technical term for the people involved. The database, that's your shared history and all the agreements you've made. And the API layer, this part's fascinating. That's basically your boundaries. It defines the rules of engagement, who gets what information, and what's expected of each person's role in the system. So once you've got the architecture set up, you need a language for the system to actually communicate, right? That brings us to protocols and response codes. This is where we create really explicit rules to manage everything from simple logistics to those really tough emotional conversations. There are two main protocols here. Think of synchronous communication like a phone call. It's happening in real time, it's ordered, and you acknowledge each point before moving on. This is what you use for the heavy stuff, like working through a conflict. Then there's asynchronous communication. That's more like sending a text about groceries. It's kind of fire and forget. It doesn't need an immediate response, and if it gets dropped, it's not the end of the world. And within those protocols, you've got different delivery models. A queue is for those heavy, difficult conversations. You basically put topics on an agenda and you tackle them one by one. This is huge for preventing overload. Then you have a stream. This is for all the casual, everyday chatter, that light, continuous flow that keeps you feeling connected. The real art is knowing when a topic belongs in the stream versus when it needs to go in the queue. Now, this might be one of the most powerful tools in this entire system, response codes, just like the error codes you see on the internet. Instead of a messy argument, someone can just say, hey, I'm at a 429. That's a super clear signal for I'm overwhelmed right now. Or a 49 means we are seeing this completely differently. We have a conflict. It's this brilliant shorthand that takes the personal attack out of it and just describes the state of the system. And a 500, that's a system crash. Time for a hard reboot, everyone step away. Okay, this all sounds pretty cool in theory, but how would you actually, build it? That brings us to the recommended tech stack. These are the real-world tools you can use to bring this abstract system to life. And the real beauty of this tech stack is its clarity. Each tool has one very specific job, and those jobs don't overlap. In engineering, we call this separation of concerns, and believe me, it is the absolute key to building any system that's both robust and manageable. First up, we have Postgres. This acts as the system's single source of truth. It's your database. This is where you store all the foundational stuff. Who has what role? What are the boundaries? What specific agreements have we made? It ensures you have consistency, so you're not arguing 6 months from now about what you decided. It is the official record.
Next is RabbitMQ. This is your conflict queue. Remember when we talked about putting heavy topics in a queue? This is literally the tool for that. When a really difficult issue comes up, it goes into RabbitMQ. This forces you to process things one at a time, which is amazing for preventing that feeling of emotional overload. It makes sure every single item gets the attention it needs.
And finally, there's Redis, which functions as a cache. A good way to think of it is as storage for your relationship's stable truths. You know, your inside jokes, your shared values, all the stuff you don't need to debate anymore. By keeping this stuff easily accessible, you actually reduce the emotional load of constantly reestablishing your foundation. It just makes all your daily interactions feel faster and lighter.
So, we've got the theory, we've got the tools, but what does day-to-day life actually look like inside a system like this? That brings us to our final section, operations. This is where we see how it all comes together in practice.
So, what happens when you bring someone new into this system, like a new partner or even a nanny? Well, there's a standard operating procedure. First, you introduce their role gradually. Then you define clear boundaries using something called the principle of least privilege, which basically means you grant trust and access bit by bit, not all at once. Then you train them on the communication rules. And finally, you integrate them into the system's routines.
And the key ritual that holds us all together is the weekly stand-up meeting. Now, this isn't just a casual chat. It is a structured check-in. You review what's working, you look at the conflict queue and prioritize the top issues, you check in on emotional states, and you make decisions. This is the routine that keeps everyone aligned and stops the system from just drifting apart.
This quote right here really captures the huge mindset shift this requires. Your job is no longer to do everything or to control everyone. Your job is to manage the system. You become the integration layer that helps all the different parts work together smoothly. You go from being a control point to being a facilitator. Which leaves us with one final big question. When we apply this much engineering to something as organic and human as a connection, are we making it better, or are we accidentally changing its very nature into something else entirely? It's a fascinating question to chew on. Thanks for tuning in.